Hello children, in a previous class we discussed about the pressure exerted by the liquid column. Children, it was very important class. Maximum application questions are asked based on the previous topic only. Children, once again let us recall the factors on which pressure exerted by the liquid column depends. So children, there are 3 points which are very important. So pressure exerted by the liquid column depends on the depth of the liquid from its free surface and even density of the liquid. Okay, and third one is acceleration due to gravity. So based on that only we discussed why the walls of the dam made thicker at the bottom and even how air bubble size increases, how it grows in a size as it is moving from what we can say bottom to top. So those points are discussed. So children, in today's class the only one single point, only single topic which we are going to discuss, that is what actually Pascal's law. Children, before going to and now we can say understand the, it's very simple to understand, just forget about that to understand. Okay, before that let us try to recall one important point. Children, let us take any stationary liquid, okay, let us take it is a vessel. Okay, na? Stationary liquid, let us say it is some stationary liquid. Children, here let us take a 2 points. Let us take a point A, okay, point B. Okay, let us say it is at a depth of some x meter and it is a depth of y meter. Children, don't forget that the stationary liquid. Okay, fine. And somehow the pressure at a point A, it has some pressure, right? So that will be, let us say, some 50 Pascal. Example, the pressure at a point B is somewhat some 80 Pascal. Obviously, the pressure at a point B must, sorry. Okay, let us take it is a A and it is B. Now it is right. So pressure at a point B must be greater than the pressure at a point A. Why? Because y is greater than the x, because the depth y is greater than the depth x. Okay, children, okay, this is okay, but what is that point? And to understand means, children, now the difference between the pressure here, I want the pressure difference between, that is delta P I want, that is pressure at a point B minus pressure at a point A. Okay, so this will be how much, children? Obviously 80 minus 50, this is 30 Pascal. Am I right? Yes. What is there in that? That must tough point for so that we can't understand. It's very easy to understand the pressure difference. Children, my question is that, my point is that we are not changing the points. We are not changing the depth of the point A, depth of the point B. Will there be any chance of getting a different value for this delta P? Not at all. Why? Because it's a stationary liquid and the points are at fixed positions. So obviously pressure difference must be same. For suppose, children, first suppose at the point A, okay, now somehow by using any other techniques, you don't ask what are those techniques. Let us say at a point A, I increase some pressure. The pressure, 50 Pascal is increased to, let us say, 80 Pascal, some 60 Pascal or 70 Pascal, let us say 70 Pascal. Okay, na? Please try to understand, children. At the same point, okay, let me draw here. This is a point A only. Same point, same depth. Children, don't get confused. So now at this point, the pressure became 60 Pascal. Somehow it became a 60 Pascal. Pressure is a point B. But children, what do we know? In a stationary liquid, for a given 2 points, pressure difference must be same. So before, the pressure difference was 30. Here also 30 should be there. To have the pressure difference 30, here 60 Pascal means here pressure must be how much, children? 90 Pascal. Very important to understand. so that the pressure difference is always remains same. Always remains same. It happens only when same amount of pressure is increased at another point also. Means what? At one point you are increasing the pressure, it is transferred to the another point, and it is there also pressure is increased by same amount. Children, in a stationary liquid, the pressure difference between any given 2 points must remain same always. So this is a key point to understand what actually Pascal's law is. No, this is actually Pascal's. Of course, with a different setup, we will understand that is a different thing. But children, it's very important. So in a stationary liquid, the pressure difference between any 2 points must be same. Here, for example, children, here pressure became 100 Pascal. Then here, how much it should be? How much? 130 Pascal. Here pressure is 1000 Pascal. Here 1030 Pascal. Here pressure is 530 Pascal. Here 560 Pascal. Because as the depth is same for two given points, the pressure difference must be same. It happens only when same amount of pressure is increased at another point also. Okay, means what? At this point you are giving a pressure, it is transferred to this point also by same amount. By same amount, there is no difference at all. By same amount is increased at this point also. This is a key point to understand Pascal's law. Okay, fine. Now let us see the what actually Pascal's law statement and what does it mean, how to understand that in easy way, and even we see the some applications also. So children, here before going to discuss Pascal's law, 2 points I need to explain. One is confined liquid. Confined liquid is very important, and a free liquid. Of course, free liquid means different meanings will be there, but here we will take whatever is required to us, whatever is needed to us also. Okay, na? Fine. Children, before going to understand confined liquid, let us understand free liquid, children. So for suppose, let me take vessel. Here is liquid is taken. Let us say completely filled. Let us say A, B is surface, but this side is free to atmosphere. It's a completely filled, half filled or complete filled. Everything is okay. So what happens, you know, when you apply the force here, if you give some pressure here, liquid will come out of that vessel. It's very easy. Means I mean to say it has some chance of escaping. Let us say that escaping. Okay. Now it's like it's a free liquid actually. The liquid with the free surface, we can say that. Okay. And confined liquid means what? The liquid which is arrested. Of course, arrest word might be negative. Okay. So just imagine where it doesn't have a chance, to escape, let us say that. Then children, look at here. Now in this, let us say, just think that here. Okay, so here some liquid is taken, right? It's from all sides is closed. Can I say it's a confined liquid? Some of you say that yes sir, because water cannot escape. No, it is not confined liquid. It is a free liquid only. Why? Still here it is flowing. Look at here. Here, it is nicely it is flowing. So it should not be like this. So if this bottle is completely filled, so that even you cannot add even one drop of water also, then we can say that case confined liquid. Means what here? Confined. For example, completely closed from all sides. No chance of escaping. No chance of escaping. Okay, na? So that is actually confined liquid. The confined liquid. So we will take confined liquid only, because Pascal's law is discussed for confined liquid. That's the first point to understand. Next point, you need to understand the difference between diminished and undiminished. These 2 points also you need to understand. Diminished and undiminished. Children, diminished means what? For suppose in a hall you are talking or you are giving a speech. Children, are you sure that with whatever the loudness, the person who is sitting in the front row can hear the person who is sitting in the last row? No chance at all. Definitely there will be difference in the loudness. The front person can hear with more louder than that of the last person. Which means what? As you are talking, the sound is traveling from front row to last row. So during that process, in that situation, what happens? The intensity of the sound decreases from first to last. There we can say that sound is diminished. Sound is diminished means what? Its intensity, its loudness, whatever you may call, it decreases. Okay na? If for example with whatever the loudness the first person is hearing, if the same person, last person also can hear, then you can say that sound is undiminished. But is it possible? No, it's not that. Sound is diminished. Sound is diminished. So whenever we are talking, definitely as the sound travels, what happens? Its energy keeps on decreasing. So due to which what will happen? Its intensity, loudness decreases. So we can say that sound is diminished. Children, just a small example just I have taken. It's not that you should take this example only. You can think about any other example also. Means what here? Diminished means what? I can say the strength decreases. The strength is decreases. Undiminished means what? Strength remains same. Strength remains same. Okay, fine. So these 2 points we should keep in your mind. Means we are going to talk about confined liquid and here undiminished. These 2 words are involved in our Pascal's law. So why I am saying means many children are by-hearting the Pascal's law without understanding the terms used. So due to which what is happening, whenever they are writing an exam, they are not using keywords called confined liquid and diminished. And especially what will happen whenever teachers are correcting the papers, they will look into these scientific words, that is so called keywords. These are very important. So you can remember, I am not asking you to by heart your children. When you can understand, you can remember. See, there is so much of difference between remember and by heart. Okay. Excuse me. So you have to understand, so you can remember. And one more thing, dear children, regarding the liquid, the specialty of the liquids is that they are incompressible. They are incompressible. Compressible means what, children? Look at here. Now this ball is compressible. It is a compressible. Air is compressible. But whereas liquids are incompressible. This property of the liquid actually is giving so many benefits to us, so that we are using a hydraulic machines like anything. Okay, so in general liquids are incompressible. This is very important. Okay, fine. Now let us try to understand what actually Pascal's law is. Pascal's law is, okay, fine. So for this, children, small apparatus like a thing is there. Let us try to see that actually. So children, look at here. So here 4 identical pistons are arranged as shown in figure, and here liquid is taken. Children, now can I say that it is a what type of liquid, children? Confined liquid. Confined liquid. Confined liquid. Okay, fine. So it's very simple. And these 4 are identical pistons, which means what? Surface area is same and frictionless also. Frictionless identical pistons are considered. Okay, na? Means surface area is same only. Children, for suppose, children, here if one piston is pushed inside with 50 Newton force, example I am telling, it is noticed that this all pistons are pushed away outside with same 50 Newton. Same 50 Newton. Children, try to understand, very important. Why it is happening, children? Okay, let us do the analysis in a simple manner. As you are applying force, where? On the surface area, am I right? Yes. Okay, na? Fine. Means here, how much pressure are you giving here? Some X pressure are you giving? X pressure are you giving? Clear? Fine. And here, for suppose this is a point. This is a point. Okay, it's very important. So whatever the pressure which is given, children, very important, it is transmitted in all directions through the liquid. Means what? At every point the pressure is increased by same amount. Why? Previously we had discussion. What? The pressure difference between any 2 points must be same. It happens, means must be same. At one point you are increasing the pressure, means what? Another point also, to keep the pressure difference same, at another point also same amount of pressure must be increased. It happens only when that pressure is transmitted throughout the liquid in all directions. And that too same magnitude means what? That pressure must be undiminished. The pressure must be undiminished, which means what? Here is a confined liquid. The pressure given at any point to a confined liquid, in a confined liquid, what is happening? It is transmitted through the liquid in all directions and undiminished. This is what actually Pascal said. It's very simple. It's very simple, children. Okay, so what is the statement of the Pascal? So what is state? It states that the pressure given at any point in a confined liquid is transmitted through the liquid in all directions and undiminished. So at a particular point, you are increasing the pressure by X amount. Through the liquid at every point, pressure is increased by same amount. Pressure is increased by same amount. That's it. That is what actually Pascal's law. Got it? Got it? Fine. Now let us see the application part actually. Let us see the application part actually. So especially children, hydraulic machines can work based on this. What are the applications of Pascal's law, children? In examination, it's a direct question. Mention the applications of Pascal's law. Okay, what you can write? Hydraulic lift, hydraulic jack, okay, hydraulic press, okay, hydraulic brakes. These are the applications of Pascal's law. Now let us try to understand the principle. On which principle does a hydraulic machine work? Hydraulic machine, let us see, children. So here, here is, let us take, here is, children, you can see two vessels or two containers. Both are differ. Surface area is less, surface area is more, and these two are connected by means of horizontal pipe like this. By means of horizontal pipe, and these two are provided with not identical pistons, because you know surface areas differ. I can see that both are frictionless pistons, and here also one more piston, larger surface area, this one, let us say here. Clear? Fine. And here liquid is taken, so called confined liquid, so called confined liquid. So let us say the surface area of this piston A is small piston is A1 and the larger piston is A2. Larger piston is A2. Now children, here let F1 force is given. Let F1 force is applied on a smaller piston. F1 force. Where you are applying? F1 force is applied on the surface area is how much? A1. A1. Then can we calculate the pressure which we are giving to that confined liquid? Yes, we can. Children, we know that pressure is equal to force by area. So with that is very clear that how much pressure are we giving to the at this point? Let us say under this, take any point. So how much pressure are we giving? F1 by A1. Children, am I clear? Try to understand. How much pressure are we giving to any point to this confined liquid? Means F1 by A1 pressure we are giving. Children, according to Pascal's law, what are the pressure which you can give? That pressure is transmitted through the liquid in all directions and undiminished, means same amount. Means here pressure is increased by F1 by A1. Here also F1 by A1. Here F1 by A1. Here F1 by A1. Try to understand. Same amount. Here also F1 by A1 pressure is increased. So means what will happen? What is the pressure which you are giving, children? So it will go in this direction, because here also it is exerting, but to transfer no chance. It has to go like this. When come to this part, children, here what is the pressure is increased will act vertically upwards. What do you say? Yes. Here the pressure is acting. The pressure is acting on this larger piston. In what direction? Vertically upwards it is acting. Okay. Children, now F1 by A1, let us say P is a pressure acting on this larger piston whose surface area is A2. Then can we calculate the force acting on the larger piston? Yes, we can calculate. From this formula children, pressure is equal to force by area, we can write force is equal to pressure into area. Obviously we can write. Let us see here. So children, I want to calculate the force acting on the larger piston F2, which is equal to what? How much pressure is acting on the larger piston? P. And what is the surface area of the piston? A2. Okay. But dear children, what is the P value? P value is F1 by A1. F1 by A1. So here F2 is equal to F1 by A1 into A2. So this is very important examination point of view. We can expect the numericals based on this. We can expect the numericals based on this. Now children, just by knowing the formula, we don't understand the importance. We don't even understand the importance of the hydraulic motion unless we take a small example. Children, for suppose, how much force are we applying? Let us say 2 Newton force we are applying. How much force we are applying, ma? 2 Newton force we are applying. 2 Newton force we are applying, let us say. And the surface area of this piston is, let us say, 4 centimeters square. 4 centimeters square. And the surface of this larger piston A2 is given as some 100 centimeters square. Then how much force can exert on the larger piston? Let us use the formula. So this is 2 by 4 into 100. 4 ones are 4, 25s are. Correct? Yes. Then it will be 50 Newton. 50 Newton. Am I clear? Check once. It's 4, this one. Clear? 50 Newton. If you increase this more, for suppose it we have taken as 1000, then this will be 1000, then this will be how much children? 500 Newton. Means how much force are you giving? How much force are you exerting? Just after 2 Newton. In result, how much are we getting children? 500 Newton. 500 Newton force are we getting? Means force is multiplied. That's what children, hydraulic machines acts like a force multipliers. Very important. They multiply the force. Multipliers. Hydraulic machines acts like a force multipliers. Actually, what is the principle of hydraulic machine children? So very simple. The smaller force applied on a smaller piston produces larger force on the larger piston. Very simple. The smaller force acting on a smaller piston produces larger force on larger piston. Okay, fine. So this is what actually hydraulic machine will work. And children, then application of this hydraulic machine is very important. Very much. Let me tell you children. So children, you might have seen, whenever we can go for a, car washing, you might have seen that car is lifted and placed at a certain height. Then do you think that persons will lift and will keep there? Then for this we need all the way, Bahubali type of persons we need. It's not so easy also children. Then what do we, it's very simple. So here just see here is, let us say here is a car. Vehicle is placed on this platform. Still this underground everything we can't see that. This is a different setup will be there. I am not going to explain how that hydraulic lift work. Just I'm trying to give you an idea. So what happens children? The moment when you apply here a small force, then what will happen? Huge force is developed which is acting vertical upwards, so that our car will be lifted. Try to understand. Car will be lifted. So this how actually, in a simple way I am telling children, I am not explaining. So regarding hydraulic lift, we'll make a special video to understand that, and moreover that is not important for examination point of view. Nowhere it is asked explain how does a hydraulic lift work. No, in examination point it is not required. They don't even ask how to draw the diagram also, but the concept is important to do the numericals. Try to understand, is very very important. Okay, now, this is how actually it is a lifted. Am I clear? This is how actually hydraulic lift work actually. Small force you just exert, larger force is it's produced, which is used to lift heavy objects like this. Okay children, fine. And not only these actually, even these machines are also used to what you can say, to extract the oil from the seed oils. Further children, again I am telling, I am not explaining in detail, just I am trying to give you an idea. So here one platform, a permanent, a strong platform is constructed, and here on this one here, seeds will be there. Seeds, let us say seeds from which we want to extract the oil. Again we apply the force here. What will happen? And more force will act on the larger piston, and it is taken to the upwards. Then what will happen? These seeds are crushed. When the seeds are crushed, what will happen? Oil is extracted. Oil is means I can say that we can modify this machine. I am trying to say we can modify the machine. Okay, so not only that, here during import and export of the cotton, we know that cotton takes so much of space, volume is more actually. Okay, to compress the cotton bales also we use this. Okay, even children, to make some holes to a strong metals also we can use. How? So in that case, here for suppose if it is made like this, very sharp ones will be there. Okay, and here that metal what sheet will be there. Try to understand. Again, when you apply the force here, it is taken to the upward, then what will happen? These will be hitting again and again. Am I clear? They will be just hitting like this, so that what will happen? Holes are made. Children, again I am telling you, I am not explaining in detail, just I am trying to give you an idea how we can modify this hydraulic machine. We can modify. Okay, fine children. And here I want to give you one clarity, very very important. Hope you have copied this. If not, just kindly copy it. It's very 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 important to understand. Children, here so there will be some confusion between the applications of Pascal's law and hydraulic press. Children, in exam if they ask you to write the application of Pascal's law, what you have to write? You have to write hydraulic lift, hydraulic brake and hydraulic press. But especially sometime they may ask a question like this: on which law does a hydraulic press work? Write the applications. Hydraulic press applications they will ask you, especially hydraulic press applications. So here hydraulic press works on the Pascal's law, no doubt about it. But application means what, children? Hydraulic press I am talking. So to extract the oil from the seeds, like a groundnut so called. Okay na? And to press the cotton bales, and even to squeeze the juice from the sugar canes, we can say that. So these are the applications of what we can say hydraulic press. Okay children, so this is what actually Pascal's law and the hydraulic machine and the application. Children, there are three very very important what we can say numericals, which are very very important examination point of view. Either you can go for any term exams and annual examinations, definitely these numericals will be asked. There are three models are there. Let me try to explain that, so that it's very easy to you to do the numericals in examination. Let us the first model, children. Here model 1, the very 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 important model 1, let us say. Okay, so model 1, let us see that. Then you can look at the question also on the screen, children, here. So according to that, children, it is given that at a ground floor the pressure is given 40,000 Pascal. Children, it's better if you can make a diagram. No, it won't carry any mark, but you will get a perfect idea how to solve the numerical. Okay, fine. So here is, let me take a rough diagram. So let us say it's a ground floor. It's a ground floor and the first floor. Okay, It's a ground floor. So here at a ground floor, the pressure is given as in 40,000 Pascal. 40,000 Pascal. At the first floor, it is given as in 10,000 Pascal. 10,000 Pascal it is, fine. And so it has some height, right? Obviously height. So they are asking us to calculate the height of the first floor. It might be second floor, third floor. It's not a matter actually. It's not a matter here. And it also given that children, the density of water is given 1000 kg per meter cube, and the G value also is given 10 meter per second square. They are asking us to calculate the height of the first floor. Height of the first floor. Children, by seeing this type of numericals, we can guess the answer. See, you can here. So try here 4 is there. What is there? 4 minus 1 is how much? 3. Yes. You are going to get a 3 meters answer. But in exam, you cannot write like that. Let us see that, children. So we know that pressure is equal to H rho G. We know pressure P is equal to H rho G. So here the pressure is different here and here. Let us name it as a P1. Let us name it as a P2. Okay. Children, we know that here pressure is equal to H rho G. Then we get one doubt. Sir, here pressure P means should I take a P1 value or P2 value? No, it's not that. We have to take the pressure difference. It's very important. Pressure difference, that is P1 minus P2 is equal to H rho G. This is the important formula to remember. Clear? So from this, children, can you write like this? H is equal to P1 minus P2 by rho G. Yes, we can write. Now look at here. So this is 40,000 minus 10,000 by 1000 into 10. So this will be 30,000 by 10,000. Gets cancelled. So how much are you getting? H is equal to 3 meter. Over. So it's very simple. Don't make it complicated. Don't make it complicated. So this is one type of numerical where the pressure, both pressures will be given. They will ask us to calculate the height of the building. It might be first floor, second floor, third floor, what it may be. Just kindly copy it. We go to the second type of numerical. Okay, fine, children. Now look at the second model. Model 2. Model 2. Model 2. Okay. Let me cut this like this. So this question is based on hydraulic machine. This question is based on purely hydraulic machine, children. So it is given that children, my suggestion is that make a rough diagram to get a more clarity. So children, it is as per the what we can say question only. Just I am trying to make this rough diagram. Here is hydraulic machine, children. Here is a smaller piston, and the smaller piston, they said that 2 Newton force is acting, and its surface area is 10 centimeters square. And here is larger piston whose surface area is 100 centimeters square. Now they are asking how much force is exerted on the larger piston. And some students are getting confused. They are getting a problem to remember the formula, especially when we are dealing with the hydraulic machines. I am going to give one clue. Just try to follow. If you have a better idea, children, yes, you go ahead. It is not that you must follow whatever the ideas or advice which I gave. Whatever you feel comfort, you go ahead. But thing is that you have to remember and you must do well in exam. That's it. Okay, of course, I wish that. Fine. So children, no doubt it is F1 and this is A1, F2 and here is A2. So it's very simple. It is what? F1. You can please write here F1. F1. This piston is by A1. Children, this can we take it as is equal to? Yes, is equal to again F2 by this piston is by and this is A2. That's it. Children, it's over. This is how in a simple manner we have to remember. Children, if you have any other better alternate, you go ahead. Okay, now they are asking us to calculate the F2. Okay, so can I read it this formula like this? F2 is equal to F1 by A1 into A2. Yes, we can. So children, here F1 is how much? 2 Newton is given. A1 is 10. A2 is how much? 100. 0, 0 cancel. This is 20 Newton. So the answer is 20 Newton. Is that clear? Just copy, children. Fine. So let us discuss one more model. Means it's not, I cannot say that special model here is based on this second model only, but you know, in a data they may not give you the area of surface of the pistons directly. So they may tell like this here, children. Model 3. Model 3. Yes, they will give you the force which is acting on a smaller piston is, for example, 10 Newton. The question is obviously same. They'll ask us to calculate F2 only. But thing is that they will give the ratio of what we can say surface area. Surface area of pistons is given. Pistons. Let us say some 2:9, something like that. Some number will be given, 2:9, 2:, anything you can take like that. Then you make it one out. Which one is a A1 and which one is 2? Very simple. Whatever is a small value is a A1 on which F1 will be acting. So this you can take as A1, this you can take as A2 over. Now same formula only you can use, that is F2 is equal to F1 by A1 into it is A2. So let us calculate. It is 10 by 2 into 9, 2 1s are 2 5s are. So children, the process everything is same only, 45 Newton. Everything is same only. But thing is that the understanding is very important. Understanding is very important. Am I clear? So most of the cases surface areas will be given. They will ask us to calculate F2. If not, sometimes to support this much huge force, how much force to be acted on a smaller piston? Yes, they may ask F1 also. It is not compulsory that always F2 must be asked. It's not that. If they will ask F1, let us modify this formula. F1 is equal to, you have to write in that case. F1 is equal to F2 by A2 into A1. So this is how, children, that's what I am asking you to understand rather by hearting. If you by heart, children, only these two numericals only you can do it. But if you can understand any numerical which is given based on that particular concept, you will be in a position to do it. So very, very important. That's very important. Very means very much important. So understanding the concepts are important. Understanding the concepts are very important. Am I clear? Just copy it. So children, so this is what actually today's session. So in this session, just we discuss only single point, that is Pascal's law. Again, I am trying to just telling you, children, please don't by heart the Pascal's. Is very simple. Try to understand the terms involved in a Pascal's law. Then it will be very easy to us to understand. Then we discuss about hydraulic machine, how does it work, and the application part. And mainly examination point of view, children, whatever the three models which we discussed today, these are very important examination point of view. Even it's during you can go for UTs or term exams, pre-finals, if annuals, if portion is there, if this portion is there, definitely one numerical must be given, because entire concept is running around the hydraulic machine only. So here we have only two formulas we have, these children, that is pressure is equal to H rho G, pressure or pressure difference, whatever it may be, and we have one more, this one. Okay children, prepare well, write. Okay children, thank you so much, all the very best.